Use integration to find the volume of the solid generated when the line y equals x for x is greater than or equal to 1 but it's less than or equal to 4 is revolved through 2 pi radians around the x-axis. There's a volume of revolution question. Now, basically, volume of revolution, say you've got this sort of function, I don't know, y and x, and you've got some kind of a f of x, something like that. And you can call f of x kind of y. Basically, what it is, if you take any given little slither, so we'll call that little bit there, that's got a width, say, of dx, very small width, and it's got a height of f of x or y, right? So the height can be y at that point, right? So what happens is, if we take that and we square y, and then we times it by pi, and then we times it by dx, like that. What that does, well, pi r squared, this kind of, y could be thought of as the radius. So what you're effectively doing, you're doing this, and you're making like a disc. Kind of, it's not going to look great, but you're kind of making a little disc, and it's facing sort of into the thing. So you're making a tiny little disc. I'll see if I can draw it a bit better. So that's not really much better, is it? Something like that. It's got a thickness of dx, and it's got an area of pi y squared. So pi y squared is the area, and then the thickness, like that, is your dx. So pi y squared dx is the volume of this small disk that you're making by taking the y value at a given point, squaring it and timesing it by pi and timesing it by dx, right? So what happens if you have over a whole interval from a to b, so if you continue to get all these little strips, square them and times by pi, what you end up doing is getting all these tiny little discs all the way along, say from a to b at the end, and you turn the whole thing into these circular discs. So what that enables you to do is work out a volume as if you get this whole function and revolved it around this x-axis. Then that's what it kind of allows you. Just imagine if this kind of the x-axis was pointing right at you, and you've got all these y values. You're then revolving them, and you're making it look kind of like that. So it looks a lot better when you do this on something like GeoGebra if you follow the link. But what you do is, you think when you integrate and do a definite integral between a and b, what you are doing is adding up all these little rectangles. When you square them and times them by pi, and then you integrate a definite integral, what you're doing, you're adding up all these elemental little discs, the volume of them. So if I say, well, it's the integral between a and b, b and a of pi y squared dx, where the formula comes from is because you can pull, because they've all got a pi in, you can say, well, that's the same as pi times the integral from b to a of y squared with respect to x, with y being written as in terms of x, because it allows for the fact that y changes. If y didn't change, say this was a straight line, then it would just be a cylinder, and you could just work it out like that. So that's my sort of initial explanation as to where it comes from. Sorry about the drawings. Now, if we actually want to apply it to this, so what we're going to need probably is a drawing of y equals x. So y equals x, a very simple line. X-axis, y-axis, y equals x looks like that. So y equals x. We are looking at the lines x. We're bounding it between x equals 1 and x equals 4. So we're going to do that. 1 there and say 4 over here. 4, 1. And we're looking for, say, if we revolve this area, this region here, and we kind of like used this axis and like rotated it around there, what would be the volume that we make by revolving this area all the way around 2 pi degrees, 360, all the way around and back to the start, as in you're rolling it sort of into the page. The reason why it says use integration to find it is because you could just recognize that this is a frustrum, which is like a chopped off cone, and you could work out the volume like that. but we need to do it the way it says. So basically, the volume is going to be pi times the integral of, so between b and a, so that's 4 and 1, y squared dx. Well, we need y in terms of x, so y is x, so it's going to be x squared dx. So now it suddenly looks really, really easy. So it's pi times, well, x squared, the integral or the antiderivative is x cubed over 3. We need to evaluate that at 4 and 1 and then times the answer by pi. So that is going to be pi times 4 cubed over 3 minus 1 cubed over 3. Get those. 4 cubed is 64, so equals pi times 64 over 3 minus 1 over 3. So that equals 63 over 3, 63 pi over 3. 63 divided by 3 is 21, so that must be equals 21 pi, and we haven't been given any particular units, but we know it's a volume, so we'll give it units cubed.